Well, thank you, everyone, and welcome to Straight Science. Straight Science is an evening science presentation series put on by UAF Northwest Campus in Nome and UAF Alaska Sea Grant, which is far afield tonight. And both UAF Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. And we serve all peoples of the Bering Strait region, and the Bering Strait region is the homeland and waters of the Inupiaq, Yupik, and St. Lawrence Island Yupik peoples. So tonight we have a returning Straight Science speaker. She was last here in 2016 talking about tide gauges, and if anyone could make tide gauges riveting, it was Nick Kinsman. That is true. So Nick is with the Noaa, I got to look at this, the Noaa National Geodetic Survey, of which she is the Alaska Regional Advisor. So she knows a lot. And tonight we're going to hear about this is coming, and I have to say, Nick has already said beforehand, she is slightly exhausted. She has been dealing with Murbach and helping the region since it started. So this is really amazing. She's able to give us this talk tonight on top of everything else she's got going on. But it's really important and timely because this is going to focus in on the Murbach, the Typhoon Murbach that hit us hard, and talking about some of the ways, sort of this grassroots movement that I can't wait to hear about, and also how, you know, we all can do a better job collecting information that will be important for us, potentially getting disaster funding and whatnot, as well as helping others give us better predictions into the future. So with that, Nick, I will be monitoring the chat. The caller will have priority, and take it away. We're so glad you're here. Thank you so much.
Great. Thanks so much for having me. And I love this forum because it's so informal and we get to talk and have conversations. So definitely let me know if you've got questions. It's just really great to be here today. And I think just because I think it's helpful, I was introduced as being with the Geodetic Survey, and I am a geodesist with the National Ocean Service. And I feel like a lot of people don't know what that is. So if you don't know what geodesy is, it is the science of where the heck things are in space and time. That's how I like to define it. And so we deal with latitude, longitude, elevation, and any precision measurements, which relates very much to our topic at hand today. It's all about measuring and documenting the high water marks and the high water levels, the flood extents that occurred during the storm. So I'm just going to run through a whole bunch of stuff today. It's going to be a nice teaser, a nice taste for the types of data that were collected, why we go about that, how we go about it, and how that might be of use to all of you in the region. And if you've got questions, stop me at any time. This is really informal. I just want to make sure I'm getting some information out that's really hot off the GPS devices. So today I'm going to be talking about establishing records of high water marks. Like I said, the extent of the flooding and the road erosion, we want to put numbers to all the observations. So as we're getting reports of what happens during major events like this, it's really important to tie numbers to those values. If you are applying for mitigation grants, if you want to enhance models, improving the data that tells us about what the impacts might be in the future. And that helps with future National Weather Service watches, warnings, and advisories too. So in this most recent event that happened, science, surveying, and mapping professionals from all over Alaska worked together with local partners to really rapidly quantify impacts of the high water all over Western Alaska. The way they went about this yielded the most extensive, accurate, and accessible documentation of flooding and erosion that we've ever had compared to any past coastal flooding event of this scale in our state. So I'm coming to you today. I'm with the National Ocean Service, but I'm really taking my hat off because when it came to this entire effort, it was a collective interagency effort with federal and state partners, academic partners, local residents that were working with us, and volunteers from the private sector as well, just pitching in, trying to make as many of these measurements as we could because after the water rises, lots of that information disappears really quickly in the cleanup activities. And so getting that captured, there's often a short window, and it's really important to do. So I'm coming to you today sort of in a agency agnostic way, just to talk about all these efforts that came together. And it really was a uniquely grassroots response that occurred, and it was heavily informed by the response that we undertook during the 2011 storm. So during that storm in 2011, which was not as severe, I was working with the state of Alaska, and I actually led the high water mark campaign for the state of Alaska back then too. So it was really great to be able to participate in this and sort of draw all those lessons learned from that last event to make sure we were bringing our best capabilities to this one. Okay, let's see if I can advance this guy. Okay, so I brought some information along on the event. Gay and I were just talking about this. It always sort of feels silly talking about things that actually happened there in the area. So I'm going to walk through these quickly. I thought it would be sort of helpful because I pulled information from the Weather Service that was their final summary of the event, and I thought it would be nice to share with all of you. I'm not a meteorologist though, so I'll go through these quickly and just sort of walk you through the summary that was provided. This is an image from the National Hurricane Center and the Central Pacific Hurricane Center from Noaa that shows the satellite view on the Friday before the storm, when it was really, the winds were starting to hit the outlying Adak Island. So the remnants of Typhoon Merbok in the Northern Pacific Ocean sort of came and approached the Bering Sea on Thursday the 15th. The storm then transitioned to an extratropical area of low pressure, and it strengthened as it traversed the Bering Sea from southwest to northeast. Those impacts that we were seeing were first observed with really high winds in the central and western Aleutians on Friday, September 16th. And then as the storm continued to move northeast, it peaked in intensity on Friday with a central pressure of 937 millibars at 4 a.m. That is the lowest pressure ever recorded in the Bering Sea for the month of September, with data going back to 1950. And more remarkably, it appears to have been the lowest pressure recorded for any time of year along portions of the entire storm's track. So after that, it slowly weakened, but it remained really powerful as it moved through the Bering Strait on Saturday through to September 17th. And it sort of took a perfect track, bringing really strong coastal flooding, as all of you in Nome are totally aware of. And then it moved northeast into the Chukchi Sea by Saturday afternoon, September 17th, stalled out, sort of parked there for a long time, and then dissipated through Tuesday, September 20th. And it was sort of slow moving near the end there, which really exacerbated some of the lingering flooding effects. And obviously some of the results of this event, widespread flooding that left villages and towns along more than 1,000 miles of coastline inundated by floodwaters. Low-lying communities that saw peak storm surges of 10 to 12 feet. We'll take a look at some of the numbers there in Nome in just a second. And again, like I said, some of those high waters lingered for quite a while because of the storm's slow track. It was on par with a 50 to 100-year flood event in terms of some of the flood maps out there. And on September 23rd, the federal disaster declaration was signed, which did unlock federal assistance to supplement state, tribal, and local recovery efforts. Don't restart my software. There we go. Hopefully that doesn't happen. So that unlocking of federal assistance is really important to the conversation today, because lots of times those federal assistance grants require really specific documentation that's above and beyond some of the information we often capture in our photographs, our videos. The general documentation of the event isn't always specific enough to fully quantify the damages that occurred to get full recovery. So it's really helpful in getting these measurements to ensure that maximum access to funding is available with that federal disaster declaration. So really related. So this is actually, and for the caller, I'm sorry, the last one was just a picture of the storm track. This is a plot of the data at the buoy right off of the Nome Harbor. So when the storm was coming in, just some of the wave conditions out in the Bering Sea, there were wind gusts up to 76 miles per hour, seas up to 52 feet on Friday morning. And then as that hit the coastline, the buoy off the mouth of the harbor in Nome was measuring a 32-foot wave, single peak wave. So there's that buoy out there that's funded by the Army Corps of Engineers in conjunction with the port and the Alaska Ocean Observing System. And that's a real-time buoy, and it was really helpful to be able to watch and monitor the wave conditions offshore of Nome there. So there were sort of three factors that made this storm particularly unusual: the storm strength, the storm track, and the speed of its movement. So as it was tracking across, it really had the perfect conditions to amplify its strength. And so while it's common to get the hurricane force winds during the fall and winter, the strength of the storm was really historic for this time of month. Also, the track and the speed, as it was coming sort of up a straight line, it was following what we call dynamic fetch. So it was sort of moving in the same direction that it was tracking, and all the winds and waves were moving that same direction. So they kept amplifying and building in height, so that those high seas resulted sort of right at the coastal area there. Let's see, what else did I want to catch here? So that straight line of the track meant those huge seas, once they were generated, were sustained by the storm and deposited them right into the coastline. And that's really why we saw those record-breaking storm surge heights at many locations. Okay, that's enough of me talking to you about all the stuff you already know. So what was happening while all this was occurring is we were watching this. We being a lot of the federal, state, local, nonprofit science agencies that are looking to develop and build long-term flood products and erosion products and decision support tools in the state. And realizing we needed to make sure that we didn't repeat the mistakes of the past where we were not able to capture and quantify the extreme inundation levels that occurred. So we built on those lessons from the past, and all of these different entities sort of banded together in a grassroots effort. We reached out to work really closely with the emergency response efforts and with the State Emergency Operations Center to make sure we weren't getting in the way, and also supporting them if they needed our assistance. Maintaining situational awareness for opportunistic assistance, watching social media, talking to one another, looking at the very few but active sensors we do have available to just look at where the conditions were. And then we moved forward, and when it was safe to do so, efficiently collected high water marks, flood and erosion extents, and other changes to the landscape that occurred during this event. And that was done with a mix of different techniques, including survey grade GPS systems, UAS systems, so drone capabilities, and satellite systems. And being able to collect that post-event storm imagery was really helpful too. So throughout the whole process of this effort, we really were placing a strong priority on public safety and welfare. That's really paramount through everything. And the other thing was just making sure we weren't reaching out to people to ask for photos and report observations. We really wanted to make sure that that burden wasn't on residents in the region during the response, and also ensure that that information as it was occurring during the event was flowing to sources where it could be immediately used to improve the forecasts. So let me show you that here real quick. During the event, we're always working to ensure that any critical observations are going directly to the National Weather Service. And the reason for that is that those observations in real time during an event help to validate and improve the forecasts on the fly. And that information also goes directly to the State Emergency Operations Center and all the first responders. So while there's a lot of scientists that might want those observations, or a lot of sort of long-term planners that may be interested in what's occurring for long-term products, it's really important during the event that those observations, that information, those firsthand accounts, all the things that you're seeing out there on the ground are getting to the National Weather Service so that they can use that information to maximize the public safety. There's a couple ways you can do that. Lots of people like to share things on Twitter. You can do hashtag Alaska Weather, AKWX. That's a great way to get the information out to the Weather Service, but there's also a link that you can get to on the Weather Service website that allows you to submit a storm report. And I just dropped that in the chat for those that are on the call. The other things that we like to do during the event when we're not actually out there, we're sort of in solidarity with everyone. I can tell you we're all glued to our computers, our phones. We're monitoring the FAA webcams. We are monitoring social media, and we're starting to develop things like community impact slides that are projections of where the flooding might be relative to the projected heights and the forecasted heights of the storm surge, and making sure that those products can help to inform the forecasting as it's in progress. So in terms of actual observational assets on the ground, and this is where I get to talk about the, there it is, I get to talk about the tide gauges again. We have a couple tide gauges in Western Alaska. Let me put this link also up so you can get to it if you want to. Is that going to work? Copy and paste. There we go. This is the inundation dashboard for National Ocean Service. Our Tides and Currents office has lots of long-term tide stations that are operated. And I think the last time I talked in 2016, we were just putting one into Unalakleet. So that gave us an additional window to the coast with real-time water levels. During this event that occurred, we set records at 3 long-term water level stations in Western Alaska: Village Cove, Unalakleet, and Nome. And there in Nome, the water was up to 8.99 feet above local mean higher high water, which exceeds the prior record set in 2004. The observations go back to 1994. So the event was significantly larger than any past event, and also that larger than that 2011 storm as well. So that is only a small set of the observational assets that we have. We've got that buoy, we've got these water level stations, and one of the things I realized a lot of people weren't aware of during the storm, and one of the things we're going to do in the after action of this event is figure out ways to make the information more accessible, is that these are sort of like the grade A water level stations. We have some grade B water level stations that are just as useful for getting real-time information, but they're not calibrated as accurately for measuring water levels to look at sea level trends over 10 years and things like that. So there are other water level stations in Western Alaska too, and you can access those through the Alaska Ocean Observing System. Now, these stations are installed, let me drop that in there too, by a lot of different partners, including the state of Alaska, some private companies, and wherever there is a water level station that can provide additional information, it's fed through something called the Alaska Water Level Watch, which is a group that's dedicated to increasing access to real-time water levels throughout the state of Alaska and feeding that information through the Alaska Ocean Observing System portal. So anything that's red on this map has an additional water level sensor available. And this also includes those tide stations that I showed you on the last map. So you can sort of get everything here if you want to. Although the interface, we're going to work on improving a little bit so it's easier to understand and navigate. And so with this, you can get to additional sensors like one that was installed by the Geological Survey in Kotzebue, Alaska. And you can see there that captured the surge that occurred during the event. So there are additional assets out there than just what's available through the tide stations, and we definitely want to get the word out about that. So the link's in the chat, and I'll be sharing all the links I'm putting in here with Gay to make sure that that can get out to everyone if you want to follow up and sort of search around, poke around, and take a look at things later. Let's see. During the event, like I said, we're watching those water levels. There's also a large coordinated effort to utilize satellite data to try and capture peak water levels and get things documented from the air and from space. That's really hard because usually there's lots and lots and lots of clouds. One way to get around that is to use synthetic aperture radar. So that is a microwave sensor that can take photos through the clouds of the peak water levels, but it's very dependent on if the satellite happens to be over the area that is flooding during the peak flood. And so we work with the Department of Defense to make sure that the satellites are sort of turned on and watching and paying attention and snapping pictures if they're going to be passing over areas that are impacted. And then working with lots of optical sensors as well. So working with the Department of Defense to access as many satellites as possible because this is an emergency event, making sure that the full assets that are available can be collecting imagery. And with that, we can start to get ideas of what the water levels look like. There's also the projected height. So the Weather Service is putting out forecasts. And so what you're seeing on the screen now is an inundation product that is just the estimated height that water got during the event, that sort of shows you where the extents might be in the community. And so these products are built on the fly to help support the response activities and the forecasting for impacts. And they use the best available elevation model combined with whatever the forecasted water level is to look at where the water is most likely to extend to during the peak of the event. And so as the event's happening, this is sort of where we're expecting it to be. And as the forecast changes, these maps can be adjusted and really brought up to speed with the best predictions at any given time. And this is really helpful for helping people understand, like, if a roadway that would be used, you took that photo, nice. Thanks, Peter. So you can find out if the roadway is flooded or is projected to be flooded, and then that helps emergency responders direct people to take the appropriate actions based on our best guess of where the water is going to end up being. And so one of the things we're really excited about doing, given how well this event was documented, is improving products like this, making sure that these types of products are more accessible, generated faster, and are more accurate in future events, which is a huge benefit to everyone. So that was this one in particular was created by the state of Alaska, the U.S. Geological Survey, and the University of Alaska in conjunction with the National Weather Service. And it reflects the estimated height of flooding in Nome based on the observed water height. Okay, so the coordinated response activities. Sort of mentioned what we're doing during the event, watching it, waiting, talking to one another about how we might be able to respond and make sure that all the observations that are rolling in eventually are documented and quantified. But then how does that all come together? Number one, we support the response and recovery emergency responders. Then beyond that, we're focusing on collecting high water marks. So how high the water got in all the different places where there was flooding, the flood extents, how far those flood extents extended, and then anywhere there's been erosion, trying to quantify the volume of material that was moved and where that material went to is really important. So how do we do all that? It takes a big effort. So all the reports that roll in, all the imagery that's available, drives our understanding of the early assessments of impacts from flooding. So what you're seeing on the screen now is a dynamic map that was created by the state of Alaska during the most recent event. And as information was rolling into the State Emergency Operations Center, they were actually updating the color of each community to indicate if minor, moderate, or major flooding was occurring at each location. And so all of the threshold values are actually driven by Alaska-specific indicators. So you'll see, unlike in lower 48, we wouldn't call major flooding like fuel storage or power generation facilities being flooded. Like, these are very Alaska-specific terms that they've defined together between the state and the federal agencies that are involved in emergency response. And so this is a really helpful tool, because knowing what the preliminary impacts of flooding are as that's rolling into the Emergency Operations Center, as that picture gets built, it can help drive where the responders need to go to, and also where the scientists and engineers need to go to make those measurements. So obviously prioritizing areas where the most severe flooding occurs is a high priority, but sometimes the sequence we actually move in is having the scientists go out to the areas that are flooded, or less impacted by flooding, or moderately impacted, so that the emergency responders can get out to the high impact areas first. So it takes a lot of working together and collaboration. To respond to this event, I just want to acknowledge all of the different entities that I'm aware of, and I know there are more. The Alaska Division of Geological and Geophysical Surveys, Mining, Land, and Water Division, the U.S. Geological Survey, Department of Transportation was out there measuring things and taking images around the airports. multiple parts of the University of Alaska Fairbanks. So a shout out to the Arctic Coastal Geoscience Lab and the International Arctic Research Center. They both had UAS systems out taking photos, imagery from UAS systems and collecting measurements on the ground. Army Corps of Engineers and volunteer licensed surveyors were out collecting measurements too. So beyond just collecting the data, one of the things I'm really proud of with the effort that happened here was focusing on getting the data quickly accessible to the State Emergency Operations Center and publicly available. And so there was a lot of coordination and work with the State of Alaska partners, including the Alaska Geospatial Office and the USGS, to put all the data as it was being collected in real time into tools that people could get to directly. And I'm going to show you those in just a second and give you links. Oh, and if you want to get to this story map and sort of see the map that was used by the scientists and engineers during the response to coordinate that effort, I just put a link into it there. And it's got some other tools there too, like where measurements have been made and where they haven't been and that sort of thing. Okay, so this is an example of just what it looks like to collect these high water marks. So traveling out to an area, finding the visible high water indicators. Sometimes that's a silt line, sometimes it is debris that's been washed up on the coastline. You all know what all of this looks like, but then slapping a GPS receiver, a survey grade GPS receiver on that point and getting a height and position, latitude, longitude, and height associated with it. And then a lot of metadata gets collected alongside that too. So each person that's going out takes along this standard form. They're filling that information out, they're documenting it, and they're ensuring that everything's calibrated so it's consistent from place to place and can be used for comparison purposes, can be related to satellite data or historical data, and it just sort of brings it into a common frame with the part that goes back to geodesy, the National Spatial Reference System. So the same common frame that everyone uses for latitude, longitude, and elevation. So just to show you this a little bit more, I shared with Gay a little bit earlier, and I'll send it again. There's a guide for how to record these high water marks. And one of the things that we're eager to do is help the public just become more aware of the value of having these heights documented. So if there was flooding in a building or if there was flooding on an object outside and you can see where the water got to and you know approximately when the water got there, it's fantastic practice to go out with a permanent marker and draw a line on there and label it. The water was here at this time on this date. Same thing if it's inside, you can put a piece of tape up, anything that documents that, because lots of times it takes a while for someone with a survey grade GPS system or the ability to measure that can get there. But the more places we have high water marks, the more we can understand how the different water levels varied across the region and across any individual location, because it's not just like a bathtub. It doesn't just fill up with water. There's all those nearshore dynamics that cause the water to be higher in some areas and lower than others. And the better we understand what that is like in severe storms like the one that just occurred, the better we can predict it in future events. And so getting those nuances is really important. So that's why when you take I'm going to show you in a second what all these measurements look like. That's why they collect so many different measurements in each location. It gives that variation when the areas where the waves were active, and so that created more run up and the water got higher, or in sheltered areas up rivers or in lagoons where the water effects are more dampened, but the water can get just as high. So there's a really great tool, resource from the U.S. Army Corps of Engineers that has some great tips for if the public wants to help document these high water levels. So this is an example of just putting a piece of tape up with the date and the time if there's a high water mark indicator. I love this one. This is a picture of the high water getting documented on a gravel pile out in Amonuk in 2009, an event that happened out there. Putting a nail in on a post, if you can see where the water got up to. As the rain comes in, snow comes in, things get cleaned up, the evidence goes away, but if you put a marker on it, it's captured for the long term. So in this case, the silt's gone, but by the time the survey is conducted, the surveyors and engineers can use that, and scientists can use that documented point to still make the measurement. Okay, so let me put the link in for where all these data are going. So if you want to go there and check it out, this is a map that is being hosted by the U.S. Geological Survey. It's the first time it's ever been used in Alaska. And all of the different parties and teams from all the different agencies and partners that were responding, they all submitted their data. It all got uploaded, and it's gradually being ingested and stored in this online map. And you can go, you can look at it, you can zoom in. There's photos of each high water mark in there. And if you take a look at the screen right now, you can see I clicked on Nome, and there's like dozens of measurements. That's what that big ring is. And each one of those, if you click on it, and you can zoom in and see where they all are in town, has a height associated with it to help estimate how high the water got in that part of Nome and how high the water got in general. And so these measurements are coming in from all over Western Alaska now and are, again, I can't say it enough, the best record of a high water event like this that we've ever had. And that's incredibly important to helping improve models for the future. Let's see. Okay, so I talked a little bit about the high water marks. That's that picture again. But in addition to the high water mark measurements, it's really helpful to also get post-event imagery, whether that's collected from UAS systems or from satellite imagery, as I mentioned before. And that can be really helpful because we can't measure things everywhere, but lots of times you can see in the aerial image where the water got to, where the debris lines are. And you can overlay that on an elevation model, and you can sort of backtrack out an estimate of different water level heights, even if you can't make direct measurements. So a big effort occurred after the event to capture imagery all over the state that in the areas that were affected, and push all of those drone images, the oblique images that were captured by the US Coast Guard, and any satellite imagery out to a common platform. So I put the link in there. This is the Alaska Geospatial Office's page to host all of the imagery that was collected, the geospatial imagery, so things that actually have latitude, longitude attached to them for this particular event. And there's UAS imagery, so the drone imagery from multiple sources. There's oblique imagery. And then there's a section for restricted imagery, and that is satellite imagery that we have access to during an emergency event to support response activities. And if there's anyone out in the region that wants or needs access to that satellite imagery, these are classified defense satellites that we can get the imagery from for the purposes of supporting needs on the ground. We can get you the information to access that as long as it's for the purposes of responding to this storm. That imagery is available to you. It's like half-meter high-resolution satellite imagery. So it's a really great resource to know about, and we're really eager to make that more accessible to the public moving forward. This is the first time we've been able to do something like that on an open platform like this in Alaska. Let's see. So here's just to talk a little bit more about the drone efforts. I wanted to really highlight some of the work by UAF. Chris was out on St. Paul Island. He's with the Geophysical Institute's Arctic Coastal Geoscience Lab with several students, and they had a UAS system that was able to capture aerial imagery. And then Jessica Guerin and her team from UAF and the International Arctic Research Center were able to travel around supporting both the Coast Guard and FEMA in post-event imagery collection, and also working with local residents who've been trained in the use and operation of these systems so they could collect data right in situ. So it was a fantastic program. They were able to capture an incredible amount of data very quickly, and it's all hosted publicly on that link that I just shared previously. So definitely check that out. I don't think that their imagery from Nome is available at that link. There was another group that collected the imagery in Nome that's not up on the site yet. But they have imagery from a lot of different locations. Okay, so this is just showing you again the full suite of different type of imagery that's available. So we've got the oblique imagery that's sort of taken flying along the coast, and that's often captured just sort of right after the event when the Coast Guard was flying by, making sure that the initial damages were documented as part of the assessment efforts with the Emergency Operations Center. But then the sort of follow-on activities with the UAS and the imagery collections from satellite sort of complement those efforts. And we definitely wanted to move quickly so we could do that ahead of the snow. So why are we doing all of this? I just want to close with a couple why before I open up for questions. Rapid post-storm response activities, they provide considerable benefits directly to residents and at many different timescales. So in the short term, they can support the response and recovery process. In the longer term, they're improving the models that make sure the predictions and the forecasting are better the next time around. And they improve the quality of the watches and warnings. So on different timescales, these data directly feed into improving the ability to access grant funds, documenting what actually happened, and improving our ability to predict the future around future events. The proactive all-hands approach that our region took really brought together a lot of capabilities. It was magic to see, and I really mean that. It was magic to see everyone just all hands on deck. What systems do you have? What assets do you have? How can we help out? And because of that, this really is the most extensive, accurate, and accessible documentation of a significant storm like this in Western Alaska that we've ever accomplished. And I think I had one more. So Alaskan, just the grassroots response that came from the different technical capacities, regardless of where they were housed. So everyone sort of put down their little silos. What agency do you work for? How do you need to get credit for that? Where's your funding source? And we all pulled together to make sure that we could get as many measurements collected in as short a time as possible to document this event as well as we could. It was really amazing to see that type of public service response. And then I just wanted to give a call out. Not everyone was out there collecting the data, but we had such a large scientific community, such a large engineering and research community that were following along, ready to pitch in at any given time. And that was really supportive and helpful too. And there's going to be a lot of follow-on activities, making sure that these data get organized in a way, analyzed, and incorporated into models so that they can be really maximally used for the public benefit. And with that, I just got this photo again from the Coast Guard of Golovin around the peak of the event. And I wanted to say thank you. That's a lot of information. I gave you a lot of links. I'm going to send all those to Gabe for follow-up, and we've got time for questions. So thank you.
Wow. Well, thank you, Nick Kinsman. You have, how many people were in there behind your desk? Because not only were you talking, but you have slam dunked about, I don't know, a dozen or maybe 8 or 9 of these links while you were talking flawlessly. I don't know. I was like, wow, I hope you've got help there.
No, I don't tonight, but thank you.
Yeah,
I will send them all too. And I'm sorry for the person on the phone. It was an image heavy presentation. I realized I was going through it. So we'll get you a copy of the slides too.
Well, that's very nice. I think the phone person, for whatever reason, was just as you were starting, they fell off. And I don't know if that's because they were calling from a place where the phone went out. But regardless, so while before we get into questions, now's the time to give Nick a little love, a little Straight Science audience love, and thank her for, on top of everything else she's been doing for the region and for everyone in Western Alaska. Let her know that we appreciate that, your presentation. Honestly, Nick, that was fantastic. Right off the bat, Charlie has a question. If you're ready, Nick, here we go.
Absolutely.
All right, fire it off, Charlie.
I had a hard time getting unmuted, but yeah, I really enjoyed that, and thank you. I was in the Noaa Emergency Center, and there's a lot of products there I was unaware of, and we were unaware of, and we didn't seem to have the communication with the state emergency office that we did in previous events. So we would have really benefited from the trend as the storm developed. So I just wanted to put that in there. I found it interesting that the airport had just completed improving our airport and raised the main runway a foot or so. And the projection reflects the datum from the data from the earlier survey before the work was done. So that's something that needs to be updated. But yeah, also those storm buoys would have been excellent, excellent heads up material for us. So I learned a bunch. Thank you.
Hey, no problem. And so one of the things I'm taking up on my shoulders moving forward on behalf of the interagency and partner collaboration is as after action reports. We don't want to lose the lessons learned. So I'm taking notes down about what you just mentioned and sort of improving awareness and knowledge of some of the tools for the emergency operations center there. I can send you a link to the Alaska Ocean Observing System sort of data and assets page specific to NOAA. They have a NOAA-centric dashboard that might be a really great way to monitor some of that buoy information. But one of the things that we have noticed is that these events only happen every couple of years. And from the time the last one happens to the current one, the technology changes, the people changes, the workflows all change. And so we're noticing also like ways we've gone about making sure the satellites are tasked and prioritized to look at different things. That's a different workflow than it used to be in the past. So we're sort of figuring out the new way of doing it on the fly, and definitely a lesson to learn in terms of how we can do that more efficiently in the future. So I've got these notes down, and the thing you mentioned about the airport too is really important. The Weather Service talks about those forecasted values of significance at the local level as impact decision support services, and being able to calibrate the impacts to local requirements like how high is the elevation of the airport is critically important. So if things like the airport elevation change, it's great to figure out how to get that feedback loop in so that the forecasts are directly linked to those new heights. So that's a really great after action takeaway too. Thanks for sharing that.
Anything else, Charlie?
I was on the incident command for the 2004, 2005, 2011, 2022 storms, and I've been trying to write a report. And if you read the history of NOAA, the 1913 and the 1946 storms they're really hard. You know, they're reputed to be 100-year storms, but I just wondered, is there any way to go back in time and try to calibrate the data for those to the current data?
Yeah, I mean, so I said 50-year, 100-year storms when I was walking through the talking points at the beginning of the presentation, because so that's how we think about them and talk about them classically. But we're actually stepping away from that terminology quite a bit, because there's growing recognition that the frequency of storms does not happen on a linear time cycle like that. And so classifying these storms in that way really is not all that helpful sometimes. And there's some really great histories that are being put together of like the past events that have happened, not just in NOAA, but statewide. And lots of that information is pocketed and stored in different non-digital spaces. And one of the things that I know the state of Alaska has been trying to do in collaboration with Army Corps of Engineers and other partners is just consolidate that so it can be built into some of the impact decision support tools. So if you've got a history like that that you've been putting together, it would be really great to compare notes and see how that aligns with some of the past recorded water levels.
Yeah, there's photos at the museum. I could maybe try to connect with that.
Great, and I'll put my contact info in here too. So if you want to reach out to me and just ask any follow-up questions, anyone that's on the line, please do. Nice questions in the chat too.
You do. You've got so the NOAA nugget. Okay, so I have two questions. First is on the use of DoD satellites and data collection. DoD is always talking about domain awareness, but National Weather Service is closing measurement sites. How can NOAA, and by extension, the public, get better access to weather data at more places? Good question.
Yeah, great question. And keep asking that question. It's important. This is something we're always struggling with in our region. It's really expensive to maintain and operate, especially real-time observing stations, whether that be a Met station or a water level station or an FAA web camera. The cost of the operations and maintenance increases all the time, and the budgets to sustain those don't always go up. So I think the number one thing is keep asking that question and keep asking it vocally, because that helps a lot of the agencies that do make investments in observational assets on the ground be able to reinvest in those in our region where it's so hard to sustain and maintain those observations. And once you lose them, you have to rebuild them. So I appreciate you bringing that up.
And does that answer that for you, Peter? We'll take that as a yes.
Peter and I are going to connect later on water level stations. So you've got my contact info.
All right. So another question from Lloyd Perigo is, are observations of sand on the tundra or driftwood lines useful?
Yes, I didn't put any pictures of that in, but they absolutely are. So where the sand gets up to, where the driftwood gets to, that's a really great indicator of the flood elevation and the extent. And actually in the 2011 storm, where the slush got to on the snow surface and where the driftwood was deposited on top of the snow surface was really incredible at capturing the extent of flooding as well. So all those observations are really useful, and they go away really quickly. So the driftwood gets moved around, another storm comes in, the wind blows stuff around. One way you can document those if you want to assist in documenting a really notable driftwood line or sand extent is get a stake, put the stake in the ground, and write the date and time associated with the storm on it. And by driving that stake in, that's another way that someone can come back after the fact and capture a measurement associated with like a photo you took when the evidence was still there.
All right. And who would we send those photos to? I mean,
yeah, so if you take the photo and you put a stake in the ground, the best group to contact is the State Geologic Survey, and I don't have their contact info like ready access. I can pass that along to you, Gay, but if you search for the State Geologic Survey, they have a coastal hazards division, which is sort of a central location where they're gathering the needs to go out and survey water levels. But contact anyone that's involved in floodplain mapping or management. So if you are in contact with the Army Corps of Engineers or with FEMA or anyone else that might have licensed surveyors or engineers on the ground, go for it. And lots of municipalities have those capabilities too. So if there's someone that can capture that measurement, take that photo, make sure you grab it.
Another reason why we need the National Weather Service office fully staffed and manned in Nome, reopened. Just saying. But all right, and then okay, and then Peter again, and you just touched a little on number 2, but how can we, you, us, agencies, etc., create products which are tailored for a specific community by integrating known vulnerabilities with weather information? I think you sort of did in some cases, wasn't that?
We're working on getting better at this all the time. So a lot of it's just creating a feedback loop, right? Making sure there's information flowing that the impacts that are relevant to decision making on the ground, those are quantified in a way where the forecasters can match that up to the predictions and describe the potential impacts in local terms. So rather than saying the water is going to get 3 feet above mean high water, you can say it's going to get within 2 feet below the runway surface. Saying something like that is so much more meaningful than saying some arbitrary number relative to high water. Right. Knowing where the water is going to get relative to something that's known is really important. So that's sort of a base level. But Peter, I think you're driving at the fact that we could create much more robust tools and products. Things like flood inundation maps and visualization tools, dynamic mapping tools. And one of the things we're hopeful to be able to do as a result of this big campaign that occurred with so many different partners is have the information to start being able to do that using the accumulated geospatial data that are now becoming available in Western Alaska.
All right. One of the things, I don't know if this is relevant to your lessons learned, maybe, but I received calls the evening of that big storm from some of our more remote communities to the west, and they were seeing the waves rapidly increase during a short amount of time. The wind kind of swung southwest, and then boom, the waves came up. And I would assume that was the storm surge coming with the storm. And so, you know, there was concern. That was near Diomede. It was in the middle of the night, and it got quite high water quite quickly. And I believe there was some equipment that got floated off from the little beach there. And what was helpful was, with concern, seeing that jump in the water level, there was concern for those that are further north, such as Shishmaref, and doesn't have the benefit of being able to go uphill very far. So there was the call went out, and the storm surge models were then ginned up, and it was extremely useful for, I think, for some of the communities to say, okay, between 4 a.m. and 6, whatever, you guys are going to potentially see a rise. That just was seemed like a very useful tool in your toolbox.
Yeah, so that very first link I sent in the chat, which is the storms report for the Weather Service, that's an incredibly useful thing, I think, to flag. I mean, you could do it through social media and stuff too, but if you go and you put a report in there, it goes directly to the forecast office. And that means that those observations can immediately feed into the ongoing forecasting capabilities that are occurring. So if you click on that link and you bookmark it, it's not just for flooding. Any type of storm event, whether it be a blizzard or a high wind event, any observations that are occurring, if you get those in, it's going to go directly to the forecast desk. And they use that information to improve the follow-on track for any event that's occurring. And it's invaluable to have those observations from on the ground out there, either validating what the predictions are saying or invalidating them so that those can be improved based on the best available information. We know we don't have a lot of observing assets, but we have a lot of people that are really attuned to what's happening. And in many ways, our people are one of our best observing assets. So thank you to everyone that does provide reports and observations like that, because they really do make a difference.
All right, well, that's everyone here. I mean, it's really, you open my eyes on the level of different agencies that were tuned into this storm. So I appreciate that. And my question was, because I just couldn't hear it, whether you said this was a 953 millibar low at its lowest or a 943 millibar. You said it was the strongest low for this time of year, or that time of year.
Well, I'm not a meteorologist, so I lean on the Weather Service for that information. And I'm going to go back and read the number that they gave me, because they're the experts. And I believe they said 937 millibars.
Holy cow, that's formidable. I would have been more scared if I'd known that. I would have been, oh, that is low. Oh, I thought it was like 950, which I thought was tough enough, but 937. Wow, okay.
Yeah, it says, that's from the summary report from the Weather Service, that the minimum central pressure was 937 millibars at 4 a.m. As the storm was tracking across on Friday.
Wow. All right. So with that, thank you so much, Nick. I know, thank you for everybody. Oh, you did mention you wanted to say something about Jackie Overback, and I haven't heard her name yet.
Yes, thank you for bringing that up. So Jackie Overback is helping to coordinate some of the follow-on activities of the different agencies. So she is a brand new hire at Noaa. She works with the Office for Coastal Management. They've never had an employee up here before, and so it's a brand new position, and we're so excited to have her in that role. She formerly worked for the state of Alaska on coastal hazards, and she's really going to be taking up a lot of these data and making sure that they're put into a format where they can be readily used at the most local level, and that They also get used not only in future storm forecasting products, but in long-term planning products for decadal timescales and to help inform different planning tools around climate change impacts associated with flooding and erosion. So she's a great person that's going to be taking over the reins on some of the coordination while I focus in more on the after action reports. And I wanted to mention her name because I think she should come give us Strait science at some point in the future.
Love it.
So
Yep.
Big shout out to her because she's helping to coordinate the follow-on, take some of the lift off of me.
Is she in Anchorage or Fairbanks or Juneau or?
She is located in Anchorage. She's actually
Okay.
co-located with the Alaska Ocean Observing System.
Okay.
Yep.
All right.
Yep.
Well, we'll try and get that. With that, thank you so much. Before everyone tunes out, know that the next Strait Science is going to be Thursday the 20th, same time, 6:30. Our speaker is going to be Rear Admiral Nathan Moore. He is the commander for the U.S. Coast Guard for District 17, all of Alaska. He will be giving us, we have been really asking the Coast Guard to talk to us because there's been a lot going on this year, and especially in the Bering Strait region, and a lot going on recently. And he is going to give a review of what has been going on, as well as into what is going to occur this winter and on into 2023. So the Coast Guard has a lot of, I believe they have a lot more plans for Bering Strait on their plate than they did in maybe previous years. We'll find out. So that will be Rear Admiral Nathan Moore with the U.S. Coast Guard. That will be Thursday evening, the 20th. So don't miss that one. It will be hopefully very Bering Strait centric. But not as Bering Strait centric as Nick Kinsman was tonight. And we really appreciate you and the timeliness of bringing us all this information. And just fantastic. Yeah. Thank you so much.
A lot of the links I shared are really hot off the presses. So you're some of the first to really get them in their active form. And right. I'm excited to be able to share those with you. Let's do it in Nome next time.
You bet. We'd love it. Right. We're climbing back out of COVID days. So again,
Wonderful.
Thank you all. Thank you all. If you want to stay on for 1 second, Nick, thank you all so much for coming, and onwards and upwards. Good night, everybody.